Hey, welcome to The Explainer. You ever see a big, flashy scientific study that's supposed to change everything, and then you never hear about it again? Yeah. What happens there? Well, it turns out the big, brilliant idea isn't always the most important part. The real fight, the place where good ideas win or lose, is in the methodology. It's all about how the study is built. So today we're going to run what I'm calling the research gauntlet to see how even a great idea can turn into bad science and why a little bit of prevention is worth everything. This quote right here from a 2023 paper really sets the stage for our whole conversation. An ounce of methodological prevention is worth a pound of cure. I mean, think about that. It's basically saying that trying to salvage a badly designed study after you've already collected all the data, it's almost impossible. It's like trying to fix the foundation of a house after you've already built it. The real work, the smart work, is in the setup, building that solid foundation from the get-go, so the whole thing doesn't come crashing down later. So that brings us back to the big question. Why do so many of these studies fail to make a dent in the real world? It's not because the researchers aren't smart, that's for sure. The problem lies in all these hidden traps baked into the research process itself. It's this whole journey filled with tough choices, impossible trade-offs, and logical fallacies that can trip up anyone, even the pros. So today, we're going to pull back that curtain and see what's really going on. All right, here's the plan for today. We're going to walk through the big challenges researchers face. We'll start with making sure research is actually relevant, then talk about how to make real theoretical progress. After that, we'll dive into something called the researcher's dilemma. And finally, we'll get into the nitty-gritty of data, methods, and measurement. Stick with me, and we'll see how it all leads to building knowledge we can actually trust. Okay, let's dive into our first section, an ounce of prevention. We're talking about setting the stage for trustworthy knowledge. And this is especially crucial in fields like international business, which is what our source paper focuses on. Think about it. It's this complex mix of economics, psychology, sociology, all on a global scale. The stakes are super high, which means getting the methods right from the very beginning is absolutely non-negotiable. All right, so let's jump into challenge number 1, researching relevant issues. This is all about closing that gap between theory and reality. I mean, what's the point of a brilliant study if it doesn't solve a real problem for real people? It has to matter to someone outside the halls of academia. And here's the heart of the issue, right? On one side, you've got academics producing knowledge. And let's be honest, a lot of the time, they're writing for other academics. But over on the other side, you have managers, policymakers, people in the trenches who desperately need answers to solve urgent, real-world problems. The paper calls this the research practice gap. It's like they're in two completely different rooms, shouting at each other through a wall. They're just not connecting. So, okay, how do we bridge that gap? The paper lays out 2 really practical paths. First, something called bridging activities. Basically, researchers need to get out of the ivory tower, go serve on a corporate board, teach a class for executives, spend a sabbatical actually working in the industry. It's all about getting your hands dirty and seeing what problems people are actually struggling with. And the second path is what's called a design science approach. This just means you should study problems that decision makers actually care about and, this is key, focus on variables they can physically change. No more purely theoretical stuff. Okay, so you found a relevant question. Awesome. But now comes challenge number 2, making theoretical progress. This is about moving beyond the obvious. It's not enough to just confirm something we all kind of suspected anyway. You need to form a hypothesis that actually pushes the boundaries of what we know. Let me show you a classic example of a pretty weak hypothesis. You see this all the time. Women on a board is positively related to corporate social performance. Now, that sounds great, right? And listen, if you get a big enough data set, you're almost guaranteed to find some tiny positive connection. But so what? What does that actually tell us? It's just too vague. It's easy to prove, sure, but it doesn't really build a strong, useful theory. But now, check this out. Same core idea, but way more precise. The presence of X% of women on the board results in an increase of corporate social performance of Y%. See the difference? Suddenly you're making a specific, testable claim. This version is so much harder to prove, and that's a good thing. It means you're putting your theory on the line, giving it a real chance to fail.
Because in science, when a theory survives a really tough test like that, that's when you know you're onto something truly meaningful.
And this whole idea of testing theories brings us to one of the absolute cardinal sins in science, something called harking. It's a funny-sounding acronym, but it's serious. It stands for hypothesizing after the results are known. The best way to think about it is this. Imagine you shoot an arrow, it lands somewhere on a barn wall, and then you go and draw the bullseye around it. That's harking. You're not actually testing a pre-existing theory. You're just making up a story that fits whatever data you happen to find. This could be cherry-picking results that look good or just digging through data until something interesting pops out. It's a huge problem, and it completely derails the progress of real science. All right, let's move on to challenge number 3. And this one is a real doozy. It's the researcher's dilemma. This is this fundamental core conflict that's at the heart of designing literally any study. And the simple, brutal truth is, you can't have it all. Every single choice you make comes with a painful trade-off. A researcher named J.E. McGrath famously called this the three-horn dilemma. He said basically every study is trying to juggle 3 things at once. First, generalizability, meaning can you apply your findings to lots of different people or situations? Second, precision. How much control did you have? How accurate were your measurements? And third, realism. How much does your study actually look like the messy, real world? And here's the kicker, the dilemma. You cannot be great at all 3 in a single study. It's impossible. The moment you decide to focus on one, you automatically have to give up on the other 2. And McGrath did not mince words about this. He said a researcher either tries for some shaky compromise on 2 of them, but then gets impaled to the hilt on the 3rd horn. It's such a vivid image, right? There is no perfect study. Every single one has a built-in fundamental weakness. The difference between a good researcher and a bad one is that the good one knows exactly what their study's weakness is, and they're upfront about it. And you can see exactly how this plays out in the real world. Take a field study where you're out observing people in their natural environment. That's going to be super high on realism, right? But you have very little control, so it's low on precision. Now, a lab experiment is the polar opposite. You have total control, so it's high on precision, but it's an artificial setting, so it's super low on realism. And a big sample survey? Well, that can be highly generalizable to a whole population, but it's often not very realistic or precise. See, you're always getting impaled on one of those horns. And this is why the only way to build a complete picture of anything is by using lots of different studies with different methods so they can all cover for each other's blind spots. Okay, moving on to our next set of challenges, this time focusing on data, methods, and measurement. This is where the rubber really meets the road. We've got our question, we've got our design, but how do we actually collect the evidence? And more importantly, how do we know we're even measuring the thing we think we're measuring? So get this. The paper looked at 50 years of research in international business, and the results were pretty shocking. A whopping 87% of studies were purely quantitative. That's all just numbers, spreadsheets, and stats. And the authors argue this is a massive missed opportunity. Because when you bring in qualitative data, things like interviews, case studies, real human stories, you get this incredible synergy. They call it a 1 + 1 = 3 effect. The numbers are great. They tell you what is happening. But the stories, the qualitative stuff, they tell you why. And putting them together gives you a picture that is so much richer and more complete. Okay, here's another huge trap researchers can fall into. It's called the distal proxy fallacy. Now that sounds super academic, but the idea is simple. Imagine trying to measure the temperature of the sun using a kitchen thermometer. The tool just isn't right for the job, right? It's too far removed from the thing you're trying to measure. Well, that's the distal proxy fallacy. In research, a proxy is the concrete data you use to represent some big abstract idea. And the fallacy is when your data is just a terrible stand-in for the concept. The measurement might look super precise, but it's actually meaningless. And speaking of measurement, let's bust a myth that has been around for decades. You may have heard of a statistic called Cronbach's alpha. For years, the rule of thumb was, if you get a score over 0.70, your measurement is reliable. Gold star. Well, here's the reality. That's only true if a bunch of really strict assumptions are met. And in the real world, they almost never are. It's become this lazy, misleading shortcut. The paper points out there are much better, more modern tools now, like omega coefficients, that give you a way more honest look at how reliable your measurements really are. So, there you have it. We have made it through the research gauntlet. We've seen all the different ways a well-intentioned study can just go completely off the rails. And that brings us to the final payoff, the whole point of this exercise, building trustworthy knowledge. Because overcoming all these challenges, it's not just about ticking boxes for other academics. It is the only way to create knowledge that we can actually count on, knowledge that helps us make smarter decisions and, hopefully, build a better world.
So let's recap with that ounce of prevention checklist. Step 1, relevance. Always ask important questions that actually matter in the real world. Step 2, theory. Don't just go for easy wins. Form precise hypotheses that you can actually test and potentially prove wrong. Step 3, design. Be humble. Acknowledge the three-horned dilemma and be honest about the trade-offs you're making. And finally, bring it home by integrating multiple types of evidence and making sure your tools are actually measuring the thing you care about.
Because in the end, that's really what all this boils down to. Getting the methodology right isn't just some boring technical exercise. It's the engine that drives human progress. When we do it well, it allows us to take on the biggest challenges we face, from complex global issues to our own well-being. Good, tough, relevant research has the power to solve enormous problems. Which kind of leaves us with one last, really big question to think about. What problem should we point this amazing engine at next?